Hey y'all. We're going to go over another problem that involves complex inheritance patterns. Let's look at number 3 here. We'll figure out which inheritance pattern this one is following by looking at the scenario. Number 3 says, in some chickens, the heterozygous genotype leads to a phenotype known as erminette. Remember, genotype is just the code, the letters. So if it's heterozygous, that means it's different letters, right? So when you get two different letters in the genotype, this leads to a phenotype known as erminette, as far as chicken feathers go. This means that the feathers are speckled with both black and white. It says it here. It says the allele for black is B and the allele for white is W. What are the expected probabilities of the different phenotypes between two erminette chickens? So it's wanting us to obviously create a Punnett square. If it's asking us for expected probabilities, it's probably wanting us to create a Punnett square. That's really the only way we can come up with these probabilities. Now, it says between two erminette chickens. What I'm going to go ahead and do is draw my Punnett square. Looks a little funky there at the top, but hey, it's got character, right? Okay, so the question is, what do these parents look like? It says the cross is between two erminette chickens. If you look further up in the question, it says if a chicken is erminette, they are speckled with both black and white. Now, if you haven't already figured this out, the type of inheritance pattern that's going on here is codominance. Okay? I'm going to write that right over here. Codominance. Because it says the heterozygous genotype have feathers that are speckled both black and white. When you see both, or when you see co at the beginning of an inheritance pattern, or if you see that one of the phenotypes is showing two different colors at the same time, then you know it's codominance. Co means both. So if we're crossing two erminette chickens, which means they have both black and white, they must be carrying each allele, the black allele and the white allele. And we're just going to put that as both parents because it says we're crossing two erminette chickens. Let's see what the results are. BB, BW, BW, WW. All right, now we're going to come up with our probabilities. Let's look at the different possibilities for color. They can either be black with a genotype BB, they can be black and white, also known as erminette, with the genotype BW, or their phenotype can be just white with the genotype WW. What's the possibility for having a all black phenotype? Well, there's only one all black genotype, BB. Remember, each box represents 25%. So 1 out of 4 of the boxes has the homozygous B genotype. So 1 out of 4 of these chickens is there's a possibility of 25% of the chickens born being black. What about erminette? That's the heterozygous genotype. Well, there's a possibility of 2 out of 4 of the chickens, or 50% being erminette, black and white. What about white, which is the homozygous WW genotype? Just one. So 1 out of 4 possibility of getting a white chicken or 25%. All right. Hopefully that clears up the codominance inheritance pattern. I'm going to stop there.